Now we will talk about the factorization of the quadratic functions, how to do this. There are two ways, dear students, to factorize the things. The first thing, let me tell you, when we have ax squared plus bx plus c is equal to 0 if a is equal to 1. This is the easiest case, which x squared plus bx plus c is equal to 0. We find two numbers in our mind as m and n. Their product must be c, and when we find these two numbers, their sum must be b. So c is a constant. C is the constant number without variable, and b is the middle term, which is the b is the coefficient of the x, or the the power 1, x to the power of 1. So when we have this case, we write that x plus m times x plus n equals 0. So we factorize right now. Factorization finished. Now, in order to find the solution, the first one is equal to 0, we say, or second one is equal to 0. So if first one is 0, x is negative m, or if second one is equal to 0, x is negative n. These are the solutions. These are the x-intercept. These are the zeros of the function. Now, if a is different than 1, if a is different than 1, so when we have ax squared plus bx plus c is equal to 0, here the rule is a little bit changed. So we are finding two numbers in our mind such that m and n, and their product must be c. And then we are finding another two numbers like p and q, for example. P times q must be a. And then, let's be careful here, p times n, which is pn, plus q times m must be equal to coefficient of x, which is b. If these are satisfied, we say that this is x squared, so we put here x, we put here x, and we write px plus m, so px plus m times qx plus n equals 0. And then first one is factorization finished. If we want to find the roots, this is equal to 0, or the second one is equal to 0, we say. And then px plus m0 means x is negative m over p. Take the m other side, negative m, divided by p, or x is by using the same logic. If you take the n the other side, negative n divided by q. For example, here we are seeing that when the first case a is 1, even it used this one, it's same. 1 times 1 it says, so 3 times 2, so cross product 1 times 2, 2, 1 times 3, 3, 2 plus 3 it's 5, and then x plus 3 times x plus 2. Or when different than 1, so negative 15, product of two numbers such as negative 3 and 5, and 2 is product of two numbers such as 2 and 1. Now 2 times 5 will be 10. 1 times negative 3 will be 3. 10 minus 3, which is 7, so it is satisfied. When it is satisfied, we say 2x minus 3 times x plus 5, and then we continue. Now let's see the examples. Now, since a is here 1, I can directly say that two numbers such as negative 4 times 1, if I say it will be negative 4, okay, but negative 4 plus 1 will be negative 3, but I should have positive 3. For that reason, let's say this is positive 4 and this is negative 1. So the things will be x plus 4 times x minus 1 is equal to 0. Now we factorize, and then we say the first parenthesis must be 0, so x is equal to negative 4, and the second parenthesis must be 0, so x equals 1. So solution set is negative 4 comma 1. One more time here, we said that negative 4 is equal to product of two numbers, and then we said that 3 is equal to sum of given three numbers. When this is satisfied, we have written in this form and question finished. Now, second example, 6x squared minus 2x. Using the factorization, here we don't need to use the previous way. Just we can use directly the factorization by using the common terms. 6 means 2 times 3 times x instead of x squared this, and 2x is equal 0. It's clear that 2 is common. It's clear that x is common. So take the common out of the parentheses, 2x times. So here what is left? 3x. Here what is left? Just 1 is equal to 0. So we have 2x times 3x minus 1 we have is equal to 0. So product of two things 0 means the first one is 0 or the second one is 0. And then x equals 0, x equals 1 over 3. So solution set is 0 comma 1 over 3 curly braces. Now here, so if we think that two numbers, the product is 3, it could be 3 times 1. If we think two numbers product is 2, 2 times 1. So 2 times 1 is 2, 1 times 3 is 3, 2 plus 3 is 5. It's not satisfied. It is not satisfied. That means we can't use this way. We have to find something else. How could it be? But since the 3 is a prime number, let me try, guys, like this. So I am cleaning this one. Let me try like this. 3 is here right now, 1 is here, and 2 is here, 1 is up. 2 is 1 times 2, 3 is 3 times 1, and cross product 1 and 1 plus 2 and 3, which is 1 plus 6, which is 7. Bingo, it is satisfied right now. So x squared, so x and x. So we can write that 2x plus 1 times x plus 3 is equal to 0. So 2x plus 1 is 0, or x plus 3 is 0. So x is negative 1 over 2, x is negative 3. So solution set is curly braces, negative 3 comma negative 1 over 2. That's it. Now, by using the same similar things, similar logics, what can I say? Negative 6 could be negative 3 times 2, and then 6 could be 2 and 3. I am just trying it's satisfied or not. 3 times negative 3, negative 9. 2 times 2, positive 4, which is negative 5. But here I have positive 5. For that reason, let me change like that. Let me make it, this is positive 3, this is negative 2. So, what will be new thing? 3 times 3, positive 9. 2 times negative 2, negative 4. 9 minus 4, bingo, it's satisfied. And then here x. If this is a square, a. If this is y squared, y. You know this. So 2x plus 3. Do not forget, when we write the final stage, we write as a row. We write horizontally. So 2x plus 3 times 3x minus 2. When we satisfy the number 5 cross product, but when we write the equation, the factorized form horizontally, we do is equal to 0. So 2x plus 3 is equal to 0, or 3x minus 2 is equal to 0. So x equals negative 3 over 2, and here x equals positive 2 over 3. So solution set will be negative 3 over 2, comma 2 over 3. That's it. Yeah, this is the end of the video. I hope you like it. If there's any problem or